think I'm okay now. Yes, I am. So delta y is approximate, not the same with dy. You know that this is f of x plus dx minus f of x, and you know that this is f prime of x dx. And you move approximately, not equal, approximately. And you get that. So I need to, number one, find the function. Number two, find x, so the function of x. Then I have to find x, and number three, I have to find dx. And then, of course, after that, I find f prime of x. Once I have all these, I just plug it in. So which function are we looking at?
Tangent x.
What is x? Something I know a lot about and a tiny error. Like I had 99.8, where was it? I said, oh, it's very clear. It's 100 and then 0.2.
45 degrees.
Perfect. And now dx.
One degree.
1. But 45 plus 1 is not 44, but dx this time is?
-1.
Very good. Awesome. However, we have to change it into radians. In radians. Unless inside a trig function. It's not going to be inside a trig function. It's going to be outside of a trig function, so I have to change it in radians. I cannot keep it in degrees. And here's how I remember how to change from radians to degrees or vice versa. I know that this point is 180 degrees, but also pi radians. So if I want 1 degree, it's pi over 180. 1 degree is pi over 180 radians. So I have to change this into negative pi over 180. So number 3 gets changed, because I don't have enough room here, I wrote too much. So dx is basically negative pi over 180. Can anyone give us f prime?
Is it seeking squared x?
Excellent. Great job. Good. I have all the pieces, I just have to put them together. So then I have tangent 44 degrees is approximately f of x. F of x is tangent x, and x is 45. How much is tangent 45? To put it here. Let me write it. Maybe I should write it first. Tangent 45 degrees plus secant squared of 45 degrees times negative pi over 180. And now I can write the equal symbol. From here, I can write the equal symbol. From here, I cannot write the equal symbol. So tangent 45 is a nice number because sine and cosine are the same. So it must be 1. Now secant squared 45, remember secant squared or secant is 1 over cosine. So secant 45 degrees is 1 over cosine 45 degrees, which is 1 over the square root of 2 over 2, which will be 2 over the square root of 2. But then I have to square this, because I'm interested in secant squared 45 degrees, which will be 4 over 2, which is 2. So then plus 2 times negative pi over 180. So this is basically 1 minus pi over 90. I simplify 2 with 180. So I claim that tangent 44 degrees is approximately 90 minus pi over 90. And you can say, show me. and I will. Be very careful with the calculator, because when you plug in a degree, a number of degrees in tangent, you have to have the mode in degree mode. Careful with that. So I have tangent, and I plug in 44, and whatever I get, and now here, left parenthesis, 90 minus pi, this is the sign for pi, close the parenthesis, and divide by 90. Or you can just put in 1 minus pi over 90, whatever you want. So the exact is 0.965688, and our approximation is 0.96509. Any questions? Any questions?
No.
Do we feel a little bit better about these approximations using differentials? Do we need another one? Or I would like to look at a word, say it again?
I think we're good.
Okay, I'd like to look at a word problem. And then I'll stop because I have 2 questions for you on the quiz, so I would like you to start working on it. So just one more problem and then I'll stop. Okay, so the radius of a circular disc is given as, radius of a circular disc is given as 24 centimeters with a maximum error in measurement of 0.2 centimeters. Before I continue reading, I don't even know what the problem is saying or asking us to do. My question is, what does this represent and what does this represent? Based on what we've been discussing.
D4 is x and d of x is 0.2.
Thank you very much. It's very clear. This is x, this is the radius, and it has an error of 0.2. If this is my x, then this must be dx. Very good. Moving on. Use differentials to estimate the maximum error in the calculated area of the disk. Use differentials to find the area, the error in area of the disk. Now, what I would like to determine, or what I would like to discuss, is what is the area? The area is our function. This is what we are asked to determine. So I'm asked to find not delta area, which is the exact, but I'm asked to find dA, because it says use differentials. I'm asked to find dA, which is the approximation of the exact difference of the delta A. So fine, I have to start with a function. Can anyone give us the area of a disk?
Pi r squared.
Thank you very much. Perfect. And now I can ask 2 different things. I can ask A prime, or I can ask dA. This is not what we are interested in. We want to find dA, which is the differential of A. Can anyone give us the formula for the differential of A? And that's why I put them together so you understand the difference. We wrote that a few minutes ago. So what does dA represent? It's not A prime, but it's A prime times dr, because that's the variable in A. So then dA will be 2 pi r, which is a prime. When I differentiate this function, I get 2 pi r. But since this is not the derivative, but the differential of a, I have to multiply by dr. And this is the error. Error in area. Very nice. dA equals 2 times pi times 24 times 0.2. Whatever that is. So I'm going to multiply 0.4 by 24 and times pi. And I got the area, the error, 30.1593. Measurement unit. X was measured in centimeters, of course, and dx in the same measurement unit. So, what is the centimeters squared? Very good. So use differentials to estimate the maximum error in the calculator of the disk. Now, part B, because there is a part B, something called relative error. Relative error is the error divided by actual, exact. That's the relative error, relative to the exact. So we are also asked to find what is the relative error. So the relative error equals the error, which is 2 pi r dr. That was the formula. dA, maybe I should have written dA so you can see it. So it's dA over A. I just started replacing it and it's not good. I want you to see this first. Is the error over the actual, or the exact area. And this is pi r squared. They also want us to calculate that. I will always write it like this because I can simplify. So this is basically 2 times dr over r, which is twice the relative error in the radius. Twice times the relative error in radius. And now I'll plug it in. It's 2, dr is 0.2, r is 24. And I'll calculate that in a minute. Measurement unit for relative error. None. Centimeter squared over centimeter squared. Relative error, no measurement unit. Okay? So, 0.4 divided by 24, I got 0.01667. Or you can write it with the bar on top, the same thing. So no measurement unit. And now they're also asking us to write the percent error. This is 1.667%. And that was part B.